Assalamu alaikum. My name is Muhammad 𝗬𝗍𝗃𝗀𝗃 and I am going to start this presentation. The topic of presentation is analysis of a concrete bridge using BIM and 3D reconstruction technique. This is a research-oriented topic. Next slide. These are my group members. The contents that we are going to cover in this presentation are introduction, problem statement, objectives, literature review, methodology, results and conclusions, limitations and recommendations, and finally applications. So let's start with introduction. Inspection of bridges is an integral part of maintenance cycle of bridges. The current practice is the in-person visual inspection of bridges. So some portion of the bridges are accessible by foot, but as shown in the background, you can see that some places which are inaccessible requires mobilization of heavy machinery. There's a platform that is connected to a crane in the background image, and a person is inspecting the bridge. The problem with this method is that it is a tedious method and it is unsafe. Secondly, every inspector reports conditions and damages subjectively. It is a time-consuming process. Hence, there is a need for an alternate method using the latest technology that addresses these drawbacks. One possible alternate is the use of optical methods, particularly the photogrammetric method. This method allows us to capture data remotely using drones in the form of images, and it is relatively a new concept in civil engineering. What if you have a structure, a bridge in particular, but any other structure of which you have no architectural or structural plans available? Usually, cultural heritage sites don't have such plans, and many cultural heritage sites in Pakistan, for which the preservation work is almost negligible. Optical methods allows us to reverse engineer the structure. By reverse engineer here, we mean the use of an existing structure to obtain its building plans. Photogrammetry is the technique in which we take 2D overlapping images of the object and convert them into a 3D model. Optical methods of and from this 3D model, we can then reverse engineer the architectural and structural plans. All this discussion brings us to a clear understanding of identification of a problem for our project. The two problems are, number one, to explore the use of an innovative method in the visual analysis process of bridges, and number two, use and comparison of automated and manual method of generation of structural model of concrete bridge. Next. The objectives that we have achieved to solve these problems are, number one is the photogrammetric data acquisition, then point cloud model generation, mesh model generation, and the generation of BIM model, and lastly, performing structural analysis on the 3D model. Next, now Ghufran will present further.
Assalamu alaikum. I will be covering the literature review portion, which is an important part of any research-based project, which allows us to explore concepts, methods, and trends related to the project. These are the topics we reviewed. The first three correspond to photogrammetric 3D reconstruction, and the last two correspond to structural analysis. The first topic we reviewed was photogrammetric data acquisition techniques, from which we extracted these key points. For data acquisition, a high-resolution camera with a low ISO value and high aperture value is used. A low ISO value means that the image should have less noise, and a high aperture value means that each object in the image should be in focus. The subject should be in the center of the frame of the image. The images should not be blurry. The shooting technique that is ideal is such that we move in a circular path around the object while taking overlapping images such that each portion of the object is visible from at least 3 angles. Lastly, a larger data set gives better results. The second topic we reviewed was point cloud generation. A point cloud is simply a cloud that is made up of points. It is generated using a technique called structure from motion, which processes 2D images to generate 3D models. This is an automated process for which both free and paid softwares are available, and the processing can be done either on a cloud service, either using a cloud service or locally. The third topic we reviewed was 3D model generation and visual analysis. The point cloud is further processed by the software to form a hollow mesh, which is further processed to form a textured mesh, which is the final product of the reconstruction process. And that textured mesh is a representative of the subject that has been reconstructed and can be used to visually analyze the subject. The fourth topic we reviewed was automated and manual structural model. The structural model can be generated or can be made manually by drawing or by tracing the shape of the object using the point cloud as a reference. The dimensions obtained can be used in a structural analysis software to make the structural model of the object. In the automated method, the hollow mesh is converted into a solid mesh that can be imported directly into a structural analysis software. Both these models can be analyzed after assigning material properties. The last topic we reviewed was flexural modal analysis. Modal analysis is used to determine the dynamic characteristics of a structure, in particular its natural frequencies and mode shapes. Its application in the application of flexural modal analysis in pedestrian bridges is that we find the natural frequencies of the bridge and make sure that no such load acts on the bridge that may cause resonance and may lead to the bridge being damaged. This concludes the literature review part of our presentation. Hamza will take it from here.
Assalamu alaikum. Now that we are done with the literature review, I am going to explain our methodology. So these are the steps that we went through: site survey, data acquisition, data processing, and visual and model analysis. Now let's go through them one by one. Site survey. For site survey, we first of all visited the site and identified the bridge location. We planned the technique of our data acquisition, that is, we plan to use the drone to capture the images. We also identified certain hurdles like trees and bushes that might have blocked the line of sight of the drone. Lastly, we measured the thickness of the slab as a reference dimension. The next step was data acquisition. We used the drone to capture the aerial images, but due to hurdles like trees and inexperience of the pilot to fly under the bridge, we supplemented it by using the smartphone OnePlus 7. Also, to save time and to get larger video dataset, we captured the video from the smartphone from all the possible angles. The next step was the processing of the data. First of all, we extracted the images from the video by using the software 3ds Zephyr, as shown in the figure. It was very simple. We just input 60% overlap and it extracted all the 60% overlapped images. The total images extracted were about 550. In the next step, we used Agisoft Metashape to generate a point cloud model from the images. First of all, it aligned all the images by matching the overlapping features in images and generated a sparse point cloud, as can be seen in the figure. Sparse means low in quality, and this can be seen in the figure. The next step was to generate a dense or high quality point cloud, and this is the result. The difference in quality of both the clouds is easily identified. In the next step, we made a textured mesh from the dense point cloud. Meshing means that software joins the points with polygons and give it a 3D shape visualization. Now comes the analysis part. First of all, visual analysis. In this picture, the software is showing the cameras and images from which it has created the parts. Now, the mesh can be used for visual analysis. Our bridge did not have any crack, But to demonstrate, we assume that this was a crack as shown in the image by the white polygon. Now, when we drew this polygon on the image, it was also visible on the 3D mesh. If this was a crack, we could easily measure the distance in the mesh and possibly determine the dimensions of the crack, like length and width. Before model analysis, we converted the 3D mesh model into an automated solid body using the software Rhino 7 so that Abacus can recognize it as a solid body. As mentioned by Ghufran in literature review, we also made a manual BIM model from the dense point cloud in the Revit. Now, the last step was model analysis. For this, we imported the automatic and manual model in Abacus. Then we assigned the material properties and boundary conditions. And finally, we perform model analysis in 𝗏𝗏𝗃𝗃𝗃. These were the material properties that we used, and we took them from the below mentioned paper. Now Mudassir will present from here.
Assalamu alaikum. My name is Mudassir Ahmad, and I will be showing you the results of our project. Here in this slide, you can see two figures. Figure A represents the model from our work, that is the cross section of 3D reconstructed model. And on the right, figure B shows the dimensions of the cross section from a research done on the same bridge. Our model was created by tracing the lines inside the hollow portion of the point cloud model, and then the dimensions were determined. As you can see, the dimensions of each figure are comparable to each other. The major difference is in the depth of the slab, because our model also captured the flooring above the slab, whereas the figure B does not include the flooring above the slab. As discussed earlier, we performed flexure model analysis on our structure. Here are the three mode shapes of the bridge. In this slide, the results of model analysis in bending are compared with the research that is mentioned below that also determined the flexure model values of the same bridge using accelerometers. As seen from this slide, the values of automated and manual models are close to that of the reference experimental data. This shows that the model built using 3D reconstruction technique can be used to perform analysis of bridges for fairly accurate results. Conclusion. The dimensions acquired using photogrammetric method correspond to actual dimensions of the bridge. As shown previously, where the dimensions of our model and the reference model were compared. The visual analysis can be done using textured mesh for components of the bridge, as my fellow group member explained it earlier. Now I will show you the limitations and also the recommendations of our project. Weather restrictions. It is difficult to acquire data on rainy or windy days, since the camera has sensitive components that can be damaged from rainwater, and in case of high wind speed, the drone is difficult to control. So it is recommended to avoid rainy or windy days for the data acquisition for 3D reconstruction. Feasibility limitations. As the camera only captures the data from the outside shell of the structure and not the inside, the cross section is not obtained in this process. Therefore, this technique is recommended for structures having uniform materials like masonry or steel structures, heritage structure in particular whose plans are not available. It is feasible for high altitude bridges also. In order to do the structural analysis, material properties are required. Material properties can be determined by finding the strength, elastic modulus, etc. from the non-destructive testing techniques. And in case of reinforced member, X-ray scanning can be done if feasible to find the layout of the reinforcement. Hardware intensive. The process of constructing 3D model is very hardware intensive, as it requires very high processing power and brand specific GPUs. As the data set is increased, the amount of RAM required is also increased. Local processing may consume a lot of time in case the recommended hardware requirements are not met. This issue can be tackled by adopting point cloud, which requires a monthly subscription, and the data can be achieved in a matter of minutes as compared to several hours. Now, the potential applications of our project. Applicable to structural analysis of heritage structures. As mentioned earlier, the plan of heritage structures are not commonly available, so we can use 3D reconstruction technique and perform the structural analysis on the 3D reconstructed model. 3D model inventorying. The physical state of the bridge or any other structure at different points in time can be preserved digitally in the form of 3D models for the future uses, as part of preservation of history of any structure or even cities. 3D printing. As 3D printing is getting common day by day, a miniature version of the reconstructed 3D model can also be printed for studying the structure. Here is the list of references that helped in our project. That was end of our presentation. Thank you.
Okay, I have first of all, very good work, mashallah. Overall, the contribution of this work is very novel.